Dear students, in this video I will be explaining the concept of isometric projections. These concepts will be helpful to improve your imagination skills to draw the isometric drawing. First of all, you need to understand the single view or the pictorial view in order to draw the isometric drawing. Any object consisting any three-dimensional object consisting 6 different faces. But in a single view, we can't see all 6 faces. And maximum we can see 3 faces of the object. And if you orient the object in such a way that the 3 faces can be seen, and then if you see, that view is called as a single view. And here these are the 3 drawings which are representing in a single view or the pictorial view. And there are 3 forms of representing pictorial view, that is perspective view, oblique view and isometric view. If the drawings are drawn, how it appears when we see with our naked eyes, that drawings are called as perspective view. And here the drawings depends on the drawing dimensions depends on the distance between the object and the observer. For example, this is the object drawn in perspective view, and because this edge of the object is nearer to my eyes, so these dimensions are appearing with the larger dimensions. As this edge of the object is away from my eyes, so this is appearing with the small dimensions, even though these two dimensions are the same. So like that, in the perspective view, object two dimensions depends on the distance between the object and the observer. This is more realistic because when we see with our naked eyes, the dimensions of the object depends on the distance between the object and the observer. The simple example is when the flight is on the ground, and if you are seeing the flight near to the flight and its dimensions are bigger. When the flight is flying in the air, and if you see from the large distance, the dimensions of the aeroplane will be smaller because the distance between the aeroplane and yours is increased. So that is the reason the dimensions are reduced. When you see the object with our naked eyes, the dimensions will be changing according to the distance between the object and the observer. And drawing the projections with the object, when we see with the naked eyes how it appears in a similar manner, that is called as a perspective view. This is more realistic, but it is not practical to draw and it is very difficult to draw. That is why we are not concentrating on these perspective projections or the views. So because the perspective views are difficult, there is another method to draw the pictorial view, that is oblique view. So any one of the face we make the perpendicular to the view direction and we draw with the true dimensions, and other two faces are deformed and then will be drawn. So this oblique view, it is very easy to draw compared with the perspective view, but these are not realistic. And also the deformed the planes of the oblique view will actually confuse the observer to understand the object. That is why these oblique views or the projections are not in use. The next one is isometric the view. So in isometric view, all these 3 planes are oriented with the equal inclination. So if you assume this is x-axis, y-axis and z-axis, the angle between these 3 axes are made with equal dimensions, with equal angle. So this is 120 degrees, this is also 120 degrees, and this is also 120 degrees between these 2 axes. So if we make the axis with equal orientation, and if you draw the drawing, that is called as isometric the drawing or isometric view. So in this video we are actually concentrating on this isometric view. Now let us try to understand the difference between isometric projection and isometric drawing. So these two are having a little difference. Now let us say I assume a cube. This is a cube. We all know the cube consisting 6 different faces, and these are the 3 faces which I can see maximum in the isometric projection or in the isometric view. And here this actual dimensions of this object is, let us say, 1 meter, 1 meter, 1 meter. And this actual shape of this surface in the cube is a square. But here in the isometric view, this square is appearing like a rhombus. Now if you see the actual dimensions of this square, the actual dimensions of the square is like this. So if you take any one edge, the AB is the true length of the edge, that is, let us say, 1 meter. And now in the isometric view, we draw this AB as a BD, and the BD is the reduced dimensions in the isometric view. So we need to see how much is the length reduced because of the orientation. So if you see, and we need to observe two triangles. The first triangle is BDC or DBC. If you take this triangle BDC, and from BDC, BD cos 30 is equal to BC. And if you actually consider the initial triangle, that is ABC, and from the ABC triangle, because this angle is 45 degrees, now the AB cos 45 is equal to BC. So this here it is, the BC is the BD cos 30, that is equation 1, and here this is equation 2. So if equation 1 is equal to equation 2, so BD cos 30 is equal to AB cos 45. Now actually we need a relation between AB and BC. AB and the BC. So if you make equation, there BD by AB, that is equal to cos 45 by cos 30, that is equal to 0.81. And BD is the dimensions on the isometric projection or the isometric view, and AB is the true dimensions, that is the AB in the actual square. Now that means the BD is equal to 0.815 into AB. The true dimension is reduced by 81.5% in the isometric view. So that is why the true length is reduced by 81.5 in isometric projection. So when you draw the isometric projections, we need to reduce the dimensions by 81.5. Let me give one example. So let us say these are the orthographic views. In this isometric drawing, we are going to draw the three-dimensional drawing from this orthographic view. So from this orthographic view, we know this is the front view, top view, and the side view. Front view, top view, and the side view. So we need to combine these three views and draw a single 3D the drawing. That is nothing but the isometric drawing. So now let us try to draw with the true dimensions. From the orthographic views, I will take the true dimensions of this and I will draw, and I will get this diagram. So if I use the true dimensions and draw, that is called as isometric drawing. And now if I suppose I need to draw the isometric projections, so I need to reduce these dimensions by 81.5. Then the reduced dimensions will appear like this, and this is called as isometric projection. And the difference between isometric drawing and isometric projection is only dimensions are reducing, because when we make some orientation with the three planes, then the dimensions will be reduced by 81.5%. So this will be the actual isometric projection with the reduced dimensions. However, here in this video we are actually concentrating on the isometric drawing. So in the isometric drawing, we are actually taking the true dimensions, and whatever the dimension, with the same dimensions we will draw, and that is how we get this isometric drawing. For example, in the problem, if they ask to draw the isometric projection, it is not so difficult in AutoCAD. So once after you complete this isometric drawing, use a scale command and reduce the dimensions by 0.815. So then the reduced the drawing you will get, that is nothing but a isometric projection drawing. So it is very easy to convert the isometric drawing into isometric projection by multiplying by using the scale command and reduce the dimensions by 0.815. So that is why we are not actually concentrating on this isometric projection in this video, but we are concentrating on the isometric drawing. That means we will be taking the true dimensions of this object and we will be drawing the drawing that is called as isometric drawing. So here in this video we are actually concentrating on the isometric drawing. And now let us try to understand some of the important concept about isometric lines and non-isometric lines. So any lines which are the parallel to x, y and z axis, that is called as isometric line. Now for example, here in this the object, this is the x-axis, y-axis and z-axis. If any line in this 3D object is parallel to x, y or z axis, that is called as isometric lines. If the objects are not parallel to these three axes, that is called as non-isometric lines. So here this is the isometric line because it is parallel to z axis, and this is the isometric line, this is the parallel to the y axis, and like that if you see, all these lines are the isometric lines, and these isometric lines are bounded by a surface, and this surface we are calling as a principal surface. So as we discussed in the previous video, so in the isometric drawing also there will be a 4 different types of surfaces. The objects are bounded by the 4 different type of surfaces. The principal surfaces. The principal surfaces, the surfaces are parallel to any one of the principal plane. So the principal planes are bounded by these isometric lines. So that is why in one view the surface will be appearing with the true dimensions, in another two view the surface will be appearing like a line. And the another surfaces are inclined surfaces. The inclined surfaces are the bounded by the non-isometric lines. Sometimes it is the combination of isometric and non-isometric lines, but anyhow the non-isometric line must be there. And this is the inclined surface, and this is bounded by the non-isometric line, and this is the isometric line. It is the combination of both. But here the inclined surface will be visible in a two view, and in another view the inclined line will be visible. So in one view the inclined line will be visible, and in other two the views the surface will be appearing with the reduced dimensions. That is why whenever in a top view, front view or side view, if the inclined line is visible, that means there is a inclined surface. If there is a curved surface, curved line is visible in any one of the view, and we can understand that there is the curved surface. And the skew surface, let us say this is the skew surface. The skew surface is not parallel to any one of the principal plane, and it is making some angle with all the principal planes. So here this skew surface also bounded by the non-isometric lines, and this skew surface will be visible in all three different views. So based on how the surface is visible, whether in the front view, top view only, or whether it is appearing in the three views, based on that we can able to distinguish what type of surface it is. So this concept will be useful to draw the isometric drawing. Let us see the method of the drawing the isometric drawing. So first one is the block method. So in this video I am explaining about the block method to draw the isometric drawing. So according to this method we will be drawing the block by starting point concept. So this we will be drawing, and the next one is, after you draw the principal surfaces, which can be directly drawn on top view, left view, or right side view, or the front view, so wherever it is possible. So that is how we will be drawing in the next principle. And then draw the other principal surfaces which are inside the block by locating them in the third direction. So then draw the non-isometric lines and connect them to draw the inclined and skew surface. So you also remember the sequence. First we need to draw a block by using a starting point concept, and then we need to draw the principal surfaces first. If you draw the principal surfaces first, then the remaining surfaces you will be easily getting. So first we need to draw the principal surfaces, then we need to identify the other surfaces like inclined surfaces and curved surfaces or the skew surfaces, and that will be drawn in the direction. Then finally we will be identifying the non-isometric lines, and then we will complete the drawing. And that is how we will be drawing the isometric drawing by block method. Let us see some examples. Draw isometric drawing for the below orthographic views. Here if you notice, these are the three views or orthographic views: the front view, top view and side view. And this is given in the grid, and the distance between the one grid to another grid is 10 mm. So you can able to understand the dimensions of this diagram. So in isometric drawing, we need to combine these three views and draw a single object, and that is our main objective. And here you need to first see the dimensions and identify the views. And this is the front view, because we are following the first angle projection. This is the front view, this is the top view, and this is the side view. And the front view will be here, and the below the front view top view, and the next to the front view the side view according to the first angle projection. Now this side view is drawn on the left side, that means this is the right side view. And now you need to understand the dimensions of this 3D drawing. The length of the 3D drawing is given in the front view, and the height of the 3D drawing also given in the front view. The length is 40 mm, height is 30 mm, and the thickness you will come to know in the top view, that is 30 mm. So you know the length, width and the thickness. So by taking these three dimensions, you can able to draw a box. So if you see here, this is the front view, top view and side view, and this is the front view, and you draw a front view window by taking the dimensions. So here if you identify the grids, these grids are horizontal and vertical in the orthographic views. In isometric drawing, the grids are oriented with equal angle. So if you assume this is the x-axis, y-axis and z-axis, the angle between these three axes is equal. And now you know the length and width, so you will be drawing the front view box here, front view window, and this is the left side view that will be drawn on right side. So the width is 30 mm by 30 mm, so you draw another square. And this is the top view. The top view length is 40 mm and width is 30 mm, the 40 by 30, so you will be drawing this on the top of this box. So whatever you want to, wherever you wanted to start, you need to start the top view things from here, and the front view the planes here, and the side view planes here. So that is the first step. The first step, you need to identify the front view, top view and side view, and draw a box with the suitable to accommodate these three views. Then the second step, you need to identify the planes, the principal planes in any one of the view. So now I am actually considering this L shape or this shape, a red color, the plane. This plane is in the top view, and this same plane in the top view, and this is the plane, and this plane will be visible in the front view also somewhere. So if you identify, this is the width of the surface, this width is coinciding on the top over here, because this is the top view. This plane we need to see from the top of this front view, so here it is coinciding. this width is coinciding over here. Then in the similar manner, if you see the width in the side view, this is the width of the surface. This width of the surface is coinciding in the side view here. So if you see these three the views of this surface is a principal surface. So the principal surface, it will be appearing in one view the surface, in other two views it is appearing like a line. So this principal surface, it is actually locating in the top view. So you go to the top view box and draw with the dimensions. So it is 20 mm, so draw 20 mm, 10 mm, 10 mm. So you complete this diagram on the top view of the box. Now the second step is over. In the third step, again you identify any other surface. So as we already completed this surface, now let me go to this side view surface, that is like L shape. So this L shape in the front view is coinciding over here. So it is not coinciding here because this length is more and this length is only 20 mm. That is not even coinciding here, and it is only coinciding at this side. So this principal surface is coinciding at this place, and again this same principal surface or the surface is coinciding in the top view here, the top view, because here only 20 mm is there, but here in the top view if you see, so it should be having 30 mm. So it is not coinciding here, not even coinciding here, it is only coinciding at this side. That means this is also another principal surface which is appearing in the as a surface in the one view. In another two views it is appearing like this. Okay, then, and if you see in the box, the same surface will be visible over here. And again if you see the side view, it is appearing here. If you see the front view, it is appearing like this, and if you see the top view, it is appearing with the 30 mm and over here. So it is also coinciding. So you will be drawing this plane, this surface in this view, in this the box. Now you go to the next surface. The next surface is here, I am assuming. So if you see this surface in the top view, and it is coinciding over here, and if you see the same surface in the side view, it is coinciding. So if you combine, and by identifying these three surfaces together, we can understand this is also another principal surface that is seen in the front view. So here, so now again if you cross check, if you see the front view, and this surface will be visible here, and if you see the top view, it is appearing here, and if you see the side view, it is appearing over here. So it is satisfying. So this surface actual position is this. Then if you go to the next step, fifth step, you have identified three principal surfaces in three different the views. Now let us go to the surface, that is, let us say I consider this inclined line. If anywhere inclined line is there, it is belongs to inclined surface. Now this inclined line represents the inclined surface. So this inclined surface is coinciding exactly. If I draw in the top view, it is coinciding with this. That is, this is the one surface, inclined surface. And in the side view, the same inclined surface is visible here like this. So when you understand these three views together, we can understand this is the inclined surface starting from this point and ending here. In this 3D object, again if you identify this corner point, that is here, another corner point over here, and if you draw this surface to connect other two corner points, another corner point is this, that is here, another corner point is this, that is here. So you connect all these four corner points, you will get another surface, that is the inclined surface, and this 3 represents, this is the inclined surface. Then if you go to the sixth one, and there is another inclined line in the side view, that means there is another inclined surface. So this is exactly coinciding with this surface, and in the top view this is coinciding with this surface. So by combining these three views in the 3D object, so it is actually coinciding over here. So join these two lines, these 2 points, and again join these 2 points like here. So you will get the another new surface over here. So then if you go to the seventh point, so there is another surface and this surface is actually the principal surface, but initially you don't know whether it is the principal surface or not, because there is a inclined line. So this is the principal surface. Now where is it coinciding? In the front view. In the front view, if you see, this is how actually the distance you will get in the front view. So that is, it is coinciding over here, or it is also coinciding over. So it may be a here and here only, but not here, because there is no the space over here. So that means this is coinciding here or there. Then let us also check the top view. In the top view, if you check, it is not coinciding over here, it is only coinciding in the top view over here. That means this front view line will be visible here and then here. So if you see the same the principal surface in the 3D object, this is actually locating over this area. So you draw in a red color. So then it becomes a, it seventh step is over, and last eighth step, if you see, this is another principal surface, and that is actually coinciding here in the side view and in the top view here. So then if you draw this the surface in the 3D object, so it will be coming here. So that is how. Now if you see, if you make everything black, and then if you see this object, so you need to draw this line also in order to separate these two planes. So then this will be becoming a three-dimensional object, or otherwise an isometric drawing with the dimensions. Let us see one more example. Example 2. Draw isometric drawing for the below orthographic views. So here also, once after you see these three views, we need to first identify the front view, top view, side view. This is the front view, and this is the front view, and this is the top view, and this is the side view. And now in order to draw the box, we need to first consider the dimensions. In the front view, you will get the width and height. The width is this, or the length is this, 1 2 3 4 5 6 grids, so 60 mm. Height is 40 mm. So, and the thickness is, or the depth is 1 2 3 4 40 mm. So by taking these dimensions, draw a box. So this is the box we are considering to draw these views. Now you consider any one of the plane, because I will be starting from the top view. So the top view, this plane I consider. This plane in the top view, this surface in the top view is appearing in the front view here. The same surface in the side view is appearing over here. So this surface is a principal surface, and that is on the top view. So you will be drawing the top view here. Then you go to the next surface. Next I have selected this surface. All the surfaces you need to select, but one by one we will be seeing one view in one surface in the top view, one surface in the front view, and one surface in the side view, so that we will be getting the some idea about the view, about the pictorial view. So now this is the front view. In the front view, this surface is looking, and in the top view, this is coinciding with this, and in the side view, it is coinciding over here. So this surface in the front view, in the 3D object, it is over here. Then if you go to the side view, these steps, I am identifying this surface exactly coinciding in the front view over here and in the top view here. That means this surface in the side view is appearing here like this. Then if you go to the fourth surface, I am considering here. This is because there is a dotted thing here given, so this is another surface, and this surface is coinciding in the front view here, because this is the height, you see, this is the full height, so the full height is coinciding here. In the top view, the full depth is coinciding over here. That means it is exactly in the 3D the model, it is appearing here. So this is the place it is appearing. Then we will go to the next surface, that is this surface I am considering, and in the top view and in the front view this surface is here, and in the side view this surface is over here. So exactly this surface I can able to fit over here. So this is the place where it is fixed. Now if you identify, now 5 steps are over. Within these 5 steps we got some structure, and when you compare with these 3 views, we can even easily do complete the other things, but let us try to complete this model by the same procedure. And if you go to the sixth step, then the step, this surface I am considering, this is again another principal surface that is coinciding in the top view here and in the side view over here. So then this surface exactly it is fitting over here. Then if you go to the steps, there are some steps. So the top view I am considering this step. This step it is visible over here and it is also visible in the side view. So that means exactly this step is here. This step is over here. So then I will go to the next step. The next step is this, and this step will be exactly coming here. Then if you by comparing these all steps, we can understand there is one more surface here and here. So that will complete the object. Once after you complete all the object and the 3D object, then we need to check whether the front view of this object is giving the same front view, whether the top view of this object is giving whether the same object, whether the side view of this object is giving the same side view. So if everything is satisfied, and this is the actual 3D object of these 3 views. So in the reverse way, if you check the front view, the side view and the top view, you will get the same views. Only then it is cross-checked and it is correct. Let us go to the next example. This is the example. If you do it and you can able to complete any diagram, and this is one of the simple example, and let me explain. So here also first you will be identifying the front view, top view and then side view, and here there are some inclined surfaces also there, and so let us try to solve this. Now initially you will identify the width and the height. By the front view, width is 1 2 3 4 40 mm, height is 30 mm, and the depth is again 30 mm. So you draw this box in the first step, and in the second step you identify this surface in the side view appearing here and in the top view appearing over here. So in the 3D object, 3D box, this surface is appearing here in the front view. And now if you observe these the examples, in some cases I started with the top view, in some places I started with the side view, in some places I started with the front view now. So it depends on which view. If you start, it will become easy. So nothing the specific. So now I will just select this L shape or the reverse T shape. So if this is coinciding with the front view here and side view here, so if I draw the view, so it will be exactly in the top view, it is fixing here. And the similar manner, if I go to the side view, this is the plane I am considering surface. This surface is coinciding here in the front view and top view. That means if I combine these 3 views, and this surface is actually in the side view over here. So now one front view, one top view, one side view, I got it. So I got some basic structure. Then let me go to the next surface. So I selected this surface. This surface in the side view, it is appearing here, and in the top view here. That means this is also a principal surface. So this is appearing in the front view. So from the front view, it should be a parallel to the front view. If you see, it should appear. So that means if you see from this window, it should appear. So we need to draw over here. So then 5 steps are over. Let us go to the next 5 steps. Sixth step. So in the sixth step, I am actually identifying this inclined line. Inclined line represents the inclined surface. This surface is coinciding here, and this surface is coinciding over here in the top view. So now if I combine and this the 4 corners of this inclined surface, if you identify in this 3D object, so these are the 4 corners. So join all these 4 corners and it will give the another surface. And then if you go to the 7th step, and these are the 2 surfaces, and this is the another inclined line. So that means this is the inclined surface which actually representing in the top view and front view, top view and front view here. So then if you combine, this is in the 3D object. So this is starting from this corner, the one corner point, another corner point is going here. So you can able to simply locate this the inclined surface. Then if you go to the eighth step, the eighth step I am considering here. In the side view it is appearing, this surface is appearing. So in the front view it is actually coinciding here, and in the top view it is coinciding here. That means if you carefully observe, this surface is actually locating here at this place. Then if you go to the ninth step, there are two surfaces which are appearing in the front view and top view, and there is a inclined line. That means it is an inclined surface, and it is appearing like this in the front view, and it is appearing in the top view like this. So here if you identify this corner point, these corner points, and again at this position there are two more corner points, so we will get this inclined surface. So likewise again, if you the notice, there is one more surface here, these two surface, then you will get this surface. Okay, so finally this is what the actual the 3D object I required for this views. So if you cross check, it will be satisfying all the views. So that means this is the correct answer. So likewise we need to cross check and draw the models. Settings of AutoCAD screen. Because we need to draw the isometric drawing in isometric grid, so we need to make these settings. So in the grid style, we need to type grid style, and that we should keep 1, and grid, specify the grid spacing, that is 10 mm, snap, and specify snap spacing, that is 10. Again you type snap, and then the snap spacing it will ask, but here you can select yes for entering the style, and when it shows standard or isometric, you click on this isometric, or you type I for isometric, and then the vertical spacing is 10 mm. So if you make these changes, so the grid will be changing like this. So that means this is x-axis, y-axis, and z-axis, let us say. So these three are with the same equal angle. So this grid is suitable for drawing the isometric drawing. Then there is a cursor mode for isometric drawing. A box with three faces, left L, and the right side R, and the top T, which are called as isometric planes. So if you identify the cursor, so here the cursor is vertical and horizontal to this line, and the cursor here over here, these two cursors are equal to or parallel to these two lines. Whereas this cursor, if you see, these two lines are parallel to these two lines. But if you use this cursor over here or the other place, so the cursor, the cross lines will not be parallel to the plane. So in order to make it parallel or change, we can use the Ctrl E key for changing. So these cursor are also useful to draw the circles. Now for example, you need to draw a curved surface here in this plane. So at that time the circle should be appearing here. So at that time we need to use the cursor in this manner. Only then we can able to draw the curved surface here in this plane. And if you draw a circle, that should be here like this in this plane. So likewise we need to select the cursor position suitable to the plane. Then we will be starting the drawing. These worksheets can download from the link given in the description, and there are 15 diagrams. Out of 15 diagrams we will see few diagrams. Let us start with the first one. As we already discussed, first we need to change the grid setting. So if you make the orthographic grid, the grid lines are horizontal and vertical. Now to change the grid style, we need to go to snap, enter. So we need to go to the style. So S for standard, that is orthographic, and SI for isometric. So go to isometric grid, and it is asking the vertical spacing. The vertical spacing is 10. Enter and enter. So now the grid has been changed like this. Grid will be changed like this. Now if you see the grid spacing, point to point it is moving. So if you draw horizontal axis, y axis and z axis, these three will be in three different axes. Now let us say this is x axis, this is the z axis, and this is the y axis. Let us say these three are with equal angle. Now if suppose if I draw a box here, and I wanted to draw one circle in this box, let us say. So in that case I need to change the cursor. So I need to use the ellipse command than using the circle command. So now I wanted to draw one small circle in this plane. So at that time the cursor should be parallel to these two planes. So now this is not the parallel, the cross wires are not parallel to this. The cross wires are parallel to these two lines. That means I can able to draw the circle here. So if you go to the ellipse and go to ellipse, and now for ellipse, 1 minute, control 9. So go to ellipse, enter. Now I need to draw a iso circle, so go to iso circle. Now I will be taking the center as this. Now this circle is in this plane, so I can draw a circle. If the same cross wires if I use, and if I draw another circle here, this circle will be drawn, ellipse will be drawn. So take the circle somewhere, iso circle, and then if you draw a circle, so this is not actually coinciding with this plane. So at that time you need to use Control E. If you press Control E, it will be changing, keep on changing. So whenever the cross wires are equal to this plane, so then you can able to draw the circle. So in the similar manner you draw circle here, and you go to ellipse, and then mention the iso circle, then select the center. Now this circle is not in this plane, so you press Control and E, so till it becomes in this plane, it comes in this plane. So likewise we can draw the circles in different planes. So that is why we need to use these cursor settings whenever curved surface are there. Now let us try to draw the other diagrams one by one. So now if you go to the first diagram, this is the first diagram which we need to draw. So now this grid spacing I am using. So the first step is I will be closing this. So I need to identify the length, width and height. So take a line command. So the length is 1, 2, 3, 4, 5 grid size. So I will be drawing the front view. This is the right side view, so that will be on left side. So I will be drawing the front view here. So 1, 2, 3, 4, 5. Then the height is 30 mm, so 3 grid spacing. So I will complete the front view box. And this is the side view, that is the right side view, and that will be seen in the left side drawn. So it will be seen in the right side. Sorry. So I will draw this 30 mm, 1, 2, 3, 30 mm. So I will complete this. Then again I will draw the top view box. Now I need to see the this front view from this window, and this side view I should see from this window, and the top view from this above. So now any one plane I will just try to see. This is the front view. This front view should be seen from here, and this front view is coinciding at this point here in the top view, and in the front view over the here. So in the side view. So I will try to draw this plane. If I draw this plane is appearing like this. And if I draw this plane, that will be appearing here because this is coinciding with this. So I will try to draw this complete. Then if I see this, that in the side view from this window, so it cannot be coincide here, and it will be coincide over here only. So I will try to complete this. this surface here, because it will be coinciding only this place, but here there is the empty space. This plane, this surface cannot be over here, so I completed that. Then I will see this surface, that surface is coinciding here, so I will complete this surface, and the top view also this surface over here. The later, the initial, the lines I can delete it, and when I delete these things, other lines also deleted, so I will try to draw the other lines which are deleted. So then this will be the final drawing of this orthographic. The similar manner, if you go to another one, so let us go to the another one. This is very easy, this I already explained. So let me go to this fifth model. So sometimes we need not to always follow, we need not to follow always the box method only. So for your convenience, how you want to see the same manner, we can able to see. Now if you see here, actually there is a projection, and we need not to follow the box method in this case. So now let me try to draw. This is the top view. So this is the front view, and this is the side view. So this is the left side view, that is why it is drawn on right side. So the front view will be coming this side. So now let me draw only for down side I will be drawing this, the top view. So I will be first taking the 10 mm the width of in the top view. So let me take this 10 mm, and for this top view I will be taking these dimensions, that is 1 2 3 4 5 mm, 50 mm. So I will be drawing this H. So from here, so I will be drawing the H, that is 20 mm, again 20 mm, so 20 mm, and again it go on to 1 mm. So it will be going up to 1 2 3 4 mm, and then it will be going back H shape, H shape here, then again 20 mm. So I will complete this H shape here. Now if you notice it, and the thickness also given here, so I will be trying to complete this surface in the side view. And if you see in the side view, there is a two more surfaces. These two more surfaces I can complete here. So without drawing a box, I can able to draw also here by using analyzation method, or just you can imagine and you can able to draw. So this is the H, and then again if you see what is there here, so here there is a projection. So there is a projection, so we need to draw this projection. So then it is up to how much height? 10 mm height, if you see this. So 10 mm height, and then here it is 20 mm height, that we can able to see in the side view. Then here if you notice, this is the another surface which we can see here, so you can able to see, and again you can draw here and then close. So this is how you can draw this. So always we need not to draw this by using the same method. So this is the diagram for this. So if you see the top view, you will get this, and if you see the front view, you can able to see this, because here it's a plane, and sorry, this is the front view like this. So if you see, oh sorry, it is the front view, so it is actually in the reverse direction. So okay, sorry. So that means this height is up to 20 mm, and then it is the inclination taken this side. So now if you take this is actually looking like, and then this I need to draw this place to this place. Then the front view is matching, and the top view is matching, and the side view. So side view will be actually taken place from this. So this is the front view and this is the side view. So side view, there is no hidden line. So usually it should be a hidden line. If suppose if you it is taken from this side, no, this side view, the left side view, that is why it is drawn on right side. So this is the diagram. So similar manner we can complete the any number of the things. So let us go to the next diagram. So next diagram will be I will just wanted to teach this, take this. So the 10th problem. So 10th problem. So let me move this. So let me go to this problem. So here also you need not to draw the box always. So first you can start with the side view. This is the front view and this is the top view. So you can make a box from the side view. So side view, this plane we can able to see. So I will be drawing a the side view box. So that is 1 2 3 4 5 mm. So side view box will be on the right side, 1 2 3 4 5, and then the height is given 20 mm. And then again if you go to this side, the 20 mm by 20 mm, and again there is one more, the curve here taken, and then the vertically 20 mm. Then I need to draw this. So this surface I draw in this side view. So now directly from the side view I can able to draw. This is the top view, and before that I will go to the front view. The front view you can able to see this surface. So that means this surface is nothing but this. So you draw the width. How much is the width? So 1 2 3 4 5. So 1 2 3 4 only. So 4. So you can able to complete this surface. So now here if you see the side view and the top view, you can able to see this rectangle square. So this square you can complete at this place, this square, and then you can able to see the same square here in the front view. So you try to complete this. So this surface you can able to complete this. Then you will be seeing the front view. The front view here, this surface is there. So I can able to complete this surface, and you can able to see this surface also. And but when you see the top view, it is actually coinciding till here. So you can able to complete this surface. So this is how we can able to complete. So this surface is here. The top view, you see top view, and there is a L shape, and there is a another surface here. And if you see the front view, this is one surface, this is another surface, like it, and it is coinciding. So this is the another model. So we'll keep side. Then let us go to the next model. So maybe one more model I will show you. Now let me go to this model number 9. So here also it is similar to this. You can able to draw. So but here, because the width, length, everything is given, so better we will be following the box method, block method. So now you take the width. This is the front view, top view, side view. And the front view, 1 2 3 4 5 6 7 grids are there, and this is the right side view. So the front view will be on the left side. The front view will be on the right side. So now you take 1 2 3 4 5 6 7 grids, 1 2 3 4 5 6 7, and then the height is given 1 2 3 4 5. 1 2 3 4 5. So you draw one box. So this is the height 1 2 3 4 5, and the for top view the width is there 1 2 3 4 5 6. So 2 3 4 5 6. So it will be going outside, so I will be moving this little down. So now I will be completing the box. So from this box we can able to draw this. So draw this. Now you can start with the side view. There is a L shape, so draw the L shape here. So L shape here 20 mm, and from here there is a inclined line. So side view I have drawn this, and again in the for front view you can draw this. So if you draw this plane in the front view, it will be looking like this. And again in the front view and top view, if you see, this is the surface in the top. That is already inclined surface, it started and it is gone with this. So that means there is a joint from here to here. But here this is also making a, it's not direct joint. There is a 20 mm here. So take 20 mm here till here and then you join. So these imaginary lines which we have drawn earlier, that we can able to delete. And this line gone, so I will be drawing this line. So then if you see the top view is appearing. So it is also, if you see the side view, there is a line, curved line. So that means there is also a curved line from this passage from here to here. Sorry, line from here to here. Then you can delete this. So now if you see the front view, in the front view you can able to see this shape. So that is here actually, so you can able to complete this. And then it is 30 mm, so we need to actually complete 20 mm, and then you can join this. So now this is how actually it will be working.